The model of the atom is a concept that has been evolving for hundreds of years and may never stop changing. The first concept of matter and the first use of the term atom date back as far as the early Greeks. In 400 BC, Democritus, a Greek philosopher, thought matter could not be divided indefinitely. This led to the idea of atoms in a void. In 350 BC, Aristotle, also a famous Greek philosopher, modified an earlier theory that matter was made up of 4 elements: earth, fire, water, and air. Aristotle was wrong, but his theories persisted for 2,000 years. And in the 1800s, John Dalton, an English chemist and physicist, proposed a modern atomic model based on experimentation and not just pure reason. He stated that all matter is made of atoms. Atoms of an element are identical. Each element has different atoms. Atoms of different elements combined in constant ratios to form compounds, and atoms are rearranged in reactions. His ideas account for the law of conservation of mass, states that atoms are neither created nor destroyed, and the law of constant composition, stating that elements combine in fixed ratios. In the 1900s, J.J. Thomson, an English physicist, discovered electrons. He found out that materials, when rubbed, can develop a charge difference. This electricity is called cathode rays when passed through an evacuated tube. These rays have a small mass and are negative. Thomson noted that these negative subatomic particles are a fundamental part of all atoms. In 1910, Ernest Rutherford, a British physicist, performed an experiment where he shot alpha particles at gold foil. Most particles pass through, showing that atoms are mostly empty. Some positive alpha particles deflected or bounced back, thus showing that a nucleus is positive and holds most of an atom's mass. The different models of the atoms have increased in complexity over the years. First, Dalton's billiard ball model theorized that atoms are solid and indivisible, like a billiards ball. The Thomson model, the plum pudding model, showed negative electrons in a positive framework. The negative electrons are the plums encapsulated in the positive framework, which is the pudding. The Rutherford model showed that atoms are mostly empty space and negative electrons orbit a positive nucleus. At the end of the 19th century, Niels Bohr, a Danish physicist, looked further into the Rutherford model and developed the Bohr model, showing that electrons orbit the nucleus in shells rather than everywhere, and that electrons pumped up to a higher shell can be pumped up to a higher shell if hit by an electron or a photon of light. It is important to remember that there are 2 types of spectra: continuous spectra and line spectra. It is when electrons fall back down that they release a photon. They jump down from shell to shell, account for the line spectra seen in gas discharge tubes. The Bohr model is used to show covalent and ionic bonds. Another important concept is atomic number and mass number. There are 3 types of subatomic particles: electrons, protons, and neutrons. Neutrons were discovered in the 1930s. They have no charge and a mass similar to protons. Finally, elements are often symbolized with their mass number and atomic number, and these values are given on the periodic table. Another important concept is isotopes and radioisotopes. Atoms of the same element that have different numbers of neutrons are called isotopes. Due to isotopes, mass numbers are not always round numbers. Lithium 6.9 is made up of both lithium 6 and lithium 7. Often, at least one isotope is unstable. It breaks down, releasing radioactivity. These types of isotopes are called radioisotopes. This atomic model historic timeline is taught in every beginner chemistry class and shows great minds can build on ideas of our ancestor. Progress would not have been possible if these brilliant minds had not kept exploring. From 350 BC to present day, humans have never ceased to amaze.